So we define two voltages on the secondary side, and these two voltages on the secondary side will be VAB. So VAB will be the voltage at point A with respect to point B. Now if I just want to define voltage between the upper end and the center tap terminal, then it will be half of the voltage between points A and B. So this will be nothing but half VAB with signs plus minus. And if I define voltage in the second half with polarity minus plus, and if I still use the same notation VAB, then it will be nothing but minus half VAB. Minus half because I'm measuring voltage at point B with respect to center tap terminal. So voltages on the secondary side that are generated are half VAB and minus half VAB. So half VAB will go to the first envelope detector, and on the lower terminal minus half VAB will go to the second envelope detector. Whatever discussion we had in terms of the phase difference, if we now discuss the same thing between some specific voltages which are V12, half VAB and minus half VAB, then we can draw some very important phasor diagrams, and these phasor diagrams will help us to understand how conversion from FM to PM will take place. So keeping this 3 points in mind, that when input frequency is equal to carrier frequency, the phase difference between primary and secondary voltages will be 90 degree. When input frequency increases above FC, the phase difference will reduce below 90, and when the input frequency is less than carrier frequency, then the phase difference will increase above 90. So using these 3 points, let us discuss the phasor diagrams which will help us to completely understand the principle of operation. So let us discuss the phasor diagrams now. The very first phasor diagram that we are going to discuss will be for the first case in which Fin is equal to Fc. That means the input frequency is equal to the carrier frequency. Let us discuss what are the various phasors that we have in this discussion. The reference phasor is nothing but V12, which is the input voltage or voltage on the primary side. This will be the case in each and every phasor. Now if you remember that first point that we had discussed in this previous clip, that when Fin is equal to Fc, the phase difference between the primary and the secondary voltages will be 90 degree. And exactly for the same reason, if I want to draw the voltage on the secondary side, which we have called half VAB, which is the voltage across the first half of the secondary, that voltage and V12, which is the voltage on primary side, both will be 90 degree phase shifted from each other. And that's the reason when V12 is horizontal, half VAB is vertical. Similarly, the voltage across second half of the secondary will also be 90 degree phase shifted with respect to V12, but because we are measuring voltage at the lower end of the secondary, we are calling this voltage as minus half VAB. Now it is very obvious that half VAB and minus half VAB, because we are measuring these voltages at two different ends, will be 180 degree phase apart. And for exactly the same reason, you can see minus half VAB will be vertically down compared to plus half VAB. So this is my minus half VAB phasor. And when I draw the resultant phasor, so this is where we talk about the next important point. All we have to do is add the voltage on the primary side and voltage on the secondary side. So when I add the two voltages of the primary and the secondary side, then using this rectangular law of addition of two vectors, we get this vector which is the resultant vector. So the vector which I have drawn in pink color becomes the resultant vector, and as of now I'm going to give the name of VAO. We will see where is VAO in my circuit diagram. And when I add primary voltage with the voltage in the second half or the lower half of the secondary, I will get another resultant voltage or the phasor, and I'm going to call this as VBO. Now if you observe carefully, whenever Fin is equal to Fc, because of 90 degree phase difference, half VAB and minus half VAB will be exactly same in the magnitude. They are opposite in phase because of plus and minus sign. V12 is always the common voltage on the secondary side. When half VAB and minus half VAB are equal in magnitude for the first case, when you find the resultant phasors VAO and VBO, you can see both will be exactly same in their magnitudes. So that's my first phasor, which was drawn for the case Fin equal to Fc. The second phasor will be drawn for the case Fin greater than Fc.